Hello, my name is Nathan Adad, and I'm here to share with you a summary on the article Low Cost Solar Cells Poised for Commercial Breakthrough, written by Robert F. Service and published on Science.com. It goes through recent research efforts into incorporating perovskites into solar cells as a means to boost their efficiency. Before that, I'm going to walk you through how a normal solar cell works. The photon breaches the anti-reflection coating and excites an electron within the N-type silicon semiconductor, which allows it to follow its electric potential through this wire into the P-type silicon semiconductor, where it fills a vacancy. As the current's traveling through the wire, you can make it do whatever you want. You can charge a battery, you can charge your car, you can charge your phone, whatever you want. So what are perovskites? Perovskites are any material which have the same crystalline structure as titanium calcium oxide. The details of that are not exactly important. But perovskites can be used to create tandem cells which absorb a wider frequency of light. So what that means is you can put a perovskite cell in tandem with a silicon cell. Silicon only absorbs red light, but perovskites absorb blue and green. So in tandem with silicon, you can absorb red, blue, and green light. So it's a cheap boost in efficiency because perovskites are very common in nature and can also be grown in a lab setting, making them renewable. Perovskites were first used in solar cells in 2009 by Japanese researchers who got a solar cell using perovskite to reach 3.8 efficiency, which is kind of nothing compared to 25.2 efficiency we see today. But since then, perovskite solar cells have set a record of 22.1% efficiency. So they're rapidly increasing in efficiency as time goes on. Some obstacles that are in the path of current research and commercialization are stability and reliability. So if exposed to a temperature of 85 degrees Celsius or higher for a period longer than 48 hours, perovskite cells will decay. Or if they're in a moist environment, they will also decay. So you don't want your solar panel decaying within a 48-hour period, especially considering how expensive they are. But researchers have tried to work around the recipe for these perovskites, and they found out that they can take out an organic compound from the perovskites and replace it with the element cesium, and that will make it more stable, reliable, and less vulnerable to heat and humidity. And there's other minor obstacles, which aren't exactly obstacles, more of an optimization issue, where the perovskite layer, they have to find the perfect structure, because the perfect thickness and whatnot of the perovskite layer itself, how they want to structure that in comparison to the other layers and whatnot. And also finding an optimal anti-reflection coating for perovskite materials. Commercialization of perovskites is underway, and many predict perovskite solar cells will breach the efficiency of traditional silicon solar cells by the year 2020. A lot of companies are putting a lot of money in this as well. Henry Snaith, the CEO of Oxford PV, which is a perovskite specific solar cell company, raised $33 million from investors. This goes to show that a lot of people have faith in the technology. One of the issues with bringing things into the market is going from research to actual production of it. The records that are being set right now for efficiency are being set by solar cells which are the size of a postage stamp, which is not applicable to the real world where consumers will be covering the roof in solar panels. So larger prototypes are being tested by Oxford PD. Another concern in terms of commercialization is some of the most efficient perovskite solar panels use lead. Lead is a neurotoxin. It's no good for humans, any living being, actually. What people are worried about is it leaking from the cell into your roof, into the groundwater, and getting people sick. So researchers worked around that by saying, oh, we'll encapsulate the perovskite so that none of it can get out, or we'll coat the inside of the panel with sulfides so that the lead gets neutralized and binds with the sulfide. To conclude, I believe perovskites have shown great promise so far, and we're only in the research phase. A lot of companies put a lot of money, a lot of time into this, and they wouldn't do so if they weren't being backed by scientists and researchers who also truly believe that perovskite solar cells will take off. I believe using a material which is not horrible for the earth and not digging up and scarring the earth any further is also very important. So if we can incorporate perovskites into our solar cells, it's a win-win for everybody, so to speak. Here's my source. I encourage you to go look at it. Very well written article. Thank you for your time.